Welcome back to the introductory networking room on TriAcme. This is a free room that gives an introduction to networking theory and basic networking tools. In a previous class, we've looked at the networking theory, the OSI model, the TCP/IP model, and the encapsulation and decapsulation processes. Now we're going to look at the basic networking tools. Before I go on, let me start the attack bus. So as I read it loads. The first basic networking tool that I'll be looking at is ping. Now at this stage, I hope that all of the theory has made sense and you now understand the basic models behind computer networking. For the rest of the room, we'll be looking at some of the command line networking tools that we use in practical applications. Many of these tools do work on other OS, but for the sake of simplicity, we are going to be running Linux for the rest of this room. If you don't know about Linux, there are free rooms on TriAcme for Linux fundamentals, just with different OS. Just the same way we have Windows OS, we have Linux, which is open source. And we'll be looking at ping. The ping command is used when we want to test whether a connection to a remote resource is possible. Let's say I'm trying to connect to a server. Let's know if it's actually possible if the server is online. So usually this will be a website on the internet, but it could also be for a computer on your home network if you want to check if it is configured correctly. Ping works using the ICMP protocol, which is one of the slightly less well-known TCP/IP protocols that were mentioned earlier. Now you need to be prepared that we have a lot of protocols for the OSI model or the TCP/IP model, but don't overwhelm yourself. With time you're going to get familiar with them and be at the tip of your fingers. Now the ICMP protocol works on the network layer of the OSI model and thus the internet layer of the TCP/IP model. So whenever we talk about network layer of the OSI model, you should know that it correlates with the internet layer of the TCP/IP model. The basic syntax for ping is ping and the targets. We have an example here. We are trying to ping google.com to see if a network connection is possible. So just type ping google.com. So you notice that the ping command actually returns the IP address for the Google server that it's connected to, rather than the URL that was requested. This is a handy secondary application for ping, as it can be used to determine the IP address of the server hosting a website. One of the big advantages of ping is that it is pretty much ubiquitous to any network-enabled device. All operating systems support it out of the box, and even the most embedded devices can use ping. Let's have a go at the following questions, and if we have answers on the syntax, we can always go to the manual page. Now I'm going to open the terminal. This is what the command line looks like. This is a web browser based. What command would you use to ping the bbc.co.uk website? So the syntax is ping bbc.co.uk. We are good to go. Very easy. So we should ping marylandoracle.co.uk. What is the IPv4 address? So do Maryland ping maryland.co.uk. Name or service not known. Oh, I didn't add Oracle. What am I typing wrong? Okay, let's see again. MUIR. Oh, MUIR. MUI. Good. So this is the IP address here, 217.160.0.152. Enter. What switch lets you change the interval of the sent ping request? So what we are going to do here is close the connection, Control C. Then the next thing is to go to the man page. Man means manual, man ping, and we need to let us change what switch lets you change the interval of sent ping request. So we scroll through the man page and we look for interval. Okay, see, this is -i. What switch would allow you to restrict request to IPv4? Restrict request to IPv4. I think I saw, yeah. See, -4 will allow you use IPv4 only, and -6 will allow you use IPv6 only. So we have -4. What switch will give you a more verbose output? That should be -v, because every time I use my tools, -v is almost always for verbosity. Let's see. Oh, okay, I think I scrolled too much. Yeah, we have it here. -v, verbose output. So this is small letter v, and that's all. So it's very easy to use and cute to quit, and it's very basic. The next tool we are going to look out for is traceroute. Traceroute can be used to map the path your request takes at its edge to the target machine. So basically, it's not like each computer send request over a straight line. There is a protocol that ensures that whatever information is being sent goes through the best, fastest possible route. So the internet is made up of many different servers and endpoints, all networked to each other. This means that in order to get to the content you actually want, you first need to go through a bunch of other servers. Traceroute allows you to see each of these connections. It allows you to see every intermediate step between your computer and the resource that you requested. The basic syntax for traceroute on Linux is traceroute and the destination. So by default, the Windows traceroute utility, that's traceroute, operates using the same ICMP control protocol that pings, that the same protocol that ping we utilize. That's what traceroute use, and the Unix equivalent operates over UDP. Why is it disconnected? Okay, this can be altered with switches in both instances. So what we mean is that for Windows we have what we call traceroute that operates using the same ICMP protocol that ping utilizes. Now we can see that from this diagram it took 13 hops, 1 to 13, for the request to reach the destination. Now let's try before. So we are supposed to use traceroute on tryacme.com. Traceroute tryacme.com. Okay, we can see that it's working. What switch would you use to specify an interface when using traceroute? Okay, Ctrl C. Let's close that. So we are going to the man page, man traceroute. What switch would you use to specify an interface? So let's look for interface. Capital letter I is ICMP. That should be small letter I. Great. -I. What switch would you use if you wanted to use TCP SYN request when tracing the route? It's suspected to be something like T. Let's see. KRST. Okay. TCP request. Okay, here we have capital letter T. And which layer of the OSI of the TCP/IP model will traceroute run on by default. So they actually want us to think here. Should it be the internet layer or the network layer? And since we are looking at the TCP/IP model, we are going to look at the internet. Let's see, internet. Oh, great. The next one is the whois. Domain names. I'm sure you're familiar with domain names by now. They are just like the system that translates IP addresses into the website name. So we'll talk a little bit more about this next task. But for now, a domain translates into an IP address so that we don't need to remember the IP addresses of this website. So let's say TriAcme now, we have its IP address 192. Something something something. We don't need to remember all the IP addresses for the websites of interest. Domain names help us to save that stress. So domains are leased out by companies called domain registrars, and if you want a domain, you go and register with a registrar. Then you lease the domain for a certain length of time. The same way you go to school for a certain length of time, you have to register to the school and all that. Yeah. So whois? What is whois? Whois essentially allows you to query who a domain name is registered to. In Europe, personal details are redacted. However, elsewhere, you can potentially get a great deal of information from a whois search. For free users using the attack box, there is a web version of the whois tool. Let's see, talking to us. We need to install whois before using it. Okay, so if you want to install whois, this is the syntax to install that. So whois lookups are very easy to perform. This means that you don't actually need to do it from the command line. You can have it online. There is a web version that you can use to get the same information that you get from a command line instruction. Let me close this. Press Q to quit the man page. So for this, we can see that we have the domain name validation, the registrar, the relevant dates that shows the expiry date, when it was registered and when it was last updated, and the name servers. Good. Usually you get more than that. So we are going to perform a whois search on facebook.com. So this is the website, facebook.com search. So we have the information here. Can you see the registrar contacts, technical contacts, and all that? So what is the registrant's postal code for facebook.com? So we're going to the registrar's contact. Then we go to the postal code, that's 94025. 94025. When was the facebook.com domain first registered? Let's see, registration. We can see that it was first registered on 1997-03-29. The format for the answer is date, month, and year. So 29/03/1997. So we're going to perform a whois search on microsoft.com. Microsoft.com. Okay, we have it here. Press enter. Okay. What city is the registrant based in? Registrant contacts. We have city, that's Redmond. Right. What is the name of the golf course that is near the registrant address for microsoft.com? So we're going to do a little bit of OSINT here. We'll come here, so we have the address on Microsoft Way. Okay, we have, yeah, good. So this, want to close side panel. Good. So we're supposed to look for what exactly are we looking for? A golf course that is near. So this is the location, right? You're looking for a golf course. Let's see. I want all the names. Say. Oh, there's a golf course. Bellevue golf course. Bellevue. Bellevue. Hope I pronounce it right. Okay, let's see. Bellevue. Belle. Okay. Is that not it? Okay, I'm supposed to write it in full. Level golf course. Correct. What is the registered tech email for Microsoft.com? The registered tech email. This is admin contacts, technical contacts. So this is going to be it. The email. MSNHST at Microsoft.com. MSNHST at Microsoft.com. That's that. I think we're done with that. The next two we'll be looking at is dig. So how does a URL get converted to an IP address so that your computer can understand? You know, when you go to a web browser, you type in the URL, and for your computer to understand it, in bits and bytes, right? So how does it understand the IP address for that URL? So the answer is the domain name system. At the most basic level, DNS allows us to ask a special server to give us the IP address of the website we are trying to access. So let's say we made a request to google.com. Our computer will first send a request to a special DNS server. The server will then go looking for the IP address for Google and send it back to us. Our computer could then send the request to the IP of the Google server. So let's break this down a bit. When you make a request to a website, the first thing that your computer does is check its local host file to see if an explicit IP domain mapping has been created. This is an older system than DNS and much less commonly used in modern environments. However, it still takes precedence in the search order of most operating systems. Now, if no mapping has been manually created, the computer then checks its local DNS cache to see if it already has an IP address stored for the website. If it does, good. If not, it will go to the next stage of the process. Now we are assuming that the address hasn't already been found, so the computer will send a request to what is known as a recursive DNS server. This will automatically be known to the router on your network. So we are moving stage by stage. The local host, the cache. Now we're moving to the recursive DNS server that will be known by the router on the network. Now many ISPs maintain their own recursive servers, but companies such as Google and OpenDNS also control recursive servers. This is how your computer automatically knows where to send the request for information. And the details for a recursive DNS server are stored in the router or the computer. So if this website we've requested is not stored in the cache, the recursive server will pass the request on to a root name server. So the recursive server is just like the way it is in a computer, but now it's on a router. So we have what we call a root name server. A brief history. Before 2004, we had precisely 30 root name DNS servers in the world. These days, there are many more. However, they are still accessible using the same 13 IP addresses assigned to the original servers. So the root name servers essentially keep track of the DNS servers in the next level down. Choosing an appropriate one to redirect your request to, these lower level servers are called the top level domain servers. When we get to domain name system, we are going to understand what the top level domain is, what the subdomain is, and all that. The top level domain servers are split up into extensions. So for example, if you're searching for a tryacme.com, your request will go to the top, be directed to the .com top level domain server. Yeah. If you're searching for bbc.co.uk, the request will be directed to a top level domain server that handles .co.uk, like that. So as with root name servers, the TLD servers keep track of the next level down, which is the authoritative name servers. When a TLD server receives your request for information, the server passes it down to an appropriate authoritative name server. Authoritative name servers are used to store DNS records for domains directly. In other words, every domain in the world will have its DNS records stored on an authoritative name server somewhere or another. They are the source of the information. So when your request reaches the authoritative name server for the domain you are querying, it will send the relevant information back to you, allowing your computer to connect to the IP address behind the domain you requested. In summary, when you visit a website in your web browser, all this is going to happen automatically. But we can also do it manually with a tool called dig. Just like ping and traceroute, dig should be installed automatically on Linux systems. Dig allows us to manually query recursive DNS servers of our choice for information about domains, and it's a very useful tool for network troubleshooting. So we just do dig the websites or maybe the IP that we're interested in. So this is a lot of information, I know. I'm most likely interested in the answer section, but it's best that you take time to learn what the rest of this means. So for this particular one, we have the header, we have the flags. Okay, this is the answer section, question section. So we have the query time and the date that this was carried out. Let's see what we have here. Another information that this gives us is the time to live of the query DNS records. So when your computer queries a domain name, it stores the results in this local caching, and the time to live of the record tells your computer when to stop considering the record as being valid. That is when it should request the data again rather than relying on the cached copy because it could have been updated. So this particular part is the time to live, and it is in seconds. It is important to remember that time to live in the context of DNS caching is measured in seconds. So the record in the example will expire in 2 minutes and 37 seconds. For some, the time to live could mean the number of hops that it can take before it is discarded. For in the concept of DNS caching, it is measured in seconds. So what is DNS short for? Domain Name System. What is the first type of DNS server your computer would query when you search for a domain? That should be the recursive, right? What type of DNS server contains records specific to the domain extensions? That's the top level domain server. Top level domain, okay, server. Use the long version of the name. Is that supposed to be space? Okay, long version. Am I supposed to write it together? What type of DNS server contains, let me read the question very well. Top level. I'm trying to figure out how it wants me to answer. know it's top level domain, but I'm trying to can't dig. Let's see. Okay, top level domain servers. Okay, top level domain. Good. Okay, that's it. Where is the very first place your computer would look to find the IP address of a domain? That's the host file, right? The host file. Submit. Google runs two public DNS servers. One of them can be queried with the IP 8.8.8.8. What is the IP address of the other one? So we just come here, Google DNS servers. Okay. We have 8.8.4.4, 8.8.4.4. If a DNS query has a time to live of 24 hours, what number would the dig query show? Don't forget that time to live is in seconds. So if you're having 24 hours, you do 24 hours times 60 minutes times 60 seconds to convert it to seconds, and that should give us 86400. 8686400. Submit. Great. Whew. Finally, we've completed the tour of networking basics, and hopefully you found this informative. Networking is one of those things that you need to learn, and we've covered the very basics, but it would be a very good idea to continue to learn by yourself. In terms of further information, you can reach out in the TryAcme Discord room, and you can also use the Cisco self-study guide to expand your knowledge. And here we've completed this room. So I will terminate this attack box, terminate machine, and I hope with this you've been able to. What's happening? Oh, complete. So we've done this. Next, you can share on LinkedIn, Twitter, and Facebook. You can go back. So if you need to share it later, you can just come here and click on that. You can still share, right? So just giving you an overview. The next class, there's another room we'll be looking at. I think that's networking concepts, and I'm going to go to the CTF style room afterwards, so we can have like a blindfold kind of attack. Yeah, thank you so much for listening. If you have any questions, you can send them my way. I'll try my best to answer. Bye.